of linear equations. So they go hand in hand, so we're going to combine 5 and 9 together. What I've done here is I've made a list of the 5 things that I do each time I see a word problem, because all of this is talking about word problems. They're going to give it to us in words and we have to change them into equations. So this is kind of the simplest way that I can answer a word problem and make sure that I have all of the information in there. So this is going to be a really good note for you to take. So the first thing I do is define the variable. That means, what do we not know? So we have to say x equals something. That's defining the variable. X equals what? What do we not know? That's the first thing we're going to look at. Second, we're going to look what number goes with the variable. Is there a number that goes directly with what we don't know? Most of the time we're looking for a number that's being multiplied by that variable. The third thing is look at all of your other numbers and information and make sure we've used them. Look for any adding or subtracting from the variable. Look for our totals so we know what to put it equals as. Since it's an equation, we know that there's always going to be an equal sign, so we need to know what that total is. 4, make sure we've wrote the entire equation out. And then 5, we're going to solve it and of course come back and check it. So these are the 5 steps that I'm going to look for each time that I'm going through and solving a word problem. So you probably want to pause this and copy this down. So we're going to look at our first example. This is lesson 9, problem number 3 in your binder. So you're going to look at lesson 9, problem number 3 in the classwork part of your binder. And it says Marvin paid an entrance fee of $5 plus an additional $1.25 per game at a local arcade. Altogether, he spent $26.25. We need to write and solve an equation to determine how many games Marvin played. So the first thing I'm going to do, look at my notes here, is define the variable. So I'm going to look and see what do we not know. In the question it tells me we're trying to determine how many games Marvin played. So that tells me what we don't know is the number of games Marvin played. It usually tells you in the question what you're not sure of, what you're trying to find. We know he played $5. We know he paid $1.25 per game, but we don't know how many games he played. So to define my variable, I'm going to use G as my variable, and G is going to equal the number of games he played. So that's step 1. Step 2, what number goes with the variable? Is there a number that goes specifically with the number of games played? And notice I said it's usually being multiplied, and if I look up here where it says per game, that's what we don't know. I know that per means multiply. My $1.25 is really close to the number of games, which is what we don't know. So I know that the $1.25 is going to be multiplied by the number of games, which we're going to use as G. Step 3, what other numbers are there in the problem? Well, if I read through, there's an interest fee of $5 plus, that's a keyword, so I know I'm going to need $5 plus this $1.25 per game. I also need to look at any totals. We know all together means total, so all together is what it equals. He spent $26.25. So that's all of the numbers and all the keywords that we have in there. So step 4, we need to write the equation. So we kind of wrote it out as we were talking about it, so we're going to just write that condensed as an equation. $5 entrance fee plus $1.25 per game. So I know that I can just put the G right next to the $1.25. That means multiplication. Altogether equals $26.25. Now that I have the equation, step 5, I'm going to solve it and then I'm going to check. So like I told you, I'm used to drawing this river or the wall. And I know I'm trying to get this $1.25G by itself. So on the same side of that line, there is this positive 5. I know it's positive because it doesn't have a sign in front. So to get rid of this positive 5, I have to do the inverse, which is a negative, or subtract 5 from both sides. I know that's the same thing as $5 for my total here. This is a positive 125G I bring down. And I know that 2625 minus 5 is 2125. Next, I'm going to try to get rid of this multiplication between the $1.25 times G. And I know the inverse of multiplying is dividing, so I'm going to divide by $1.25 on both sides. 125 divided by 125 is just 1. And 2125 divided by 125 is 17. So we have G is equal to 17. Now this is a word problem, so we need to kind of specify what it means. We said right here, G is the number of games played, so he played 17 games. And I said last, I'm going to check my work, so I'm going to plug this 17 back into our original equation. So I'm going to do 5 plus 1.25 times the 17 and see if that equals 2625. And $1.25 times 17 is 2125. Plus 5 is equal to 2625, so I know I got this one correct. We're going to look at a second example. I'm just going to go down to problem number 4 on lesson 9 still, so the problem right below it. And it says the sum of 4 consecutive integers is negative 26. What are the integers? So I'm going to go back to my steps here and see what we have. Define the variable. So what do we not know? Well, we don't know what the consecutive integers are. We don't even know what one of the consecutive integers are. So anytime I'm faced with this, just like we've been doing, I'm going to say my x is equal to, I'm going to say the smallest integer. You have to choose one of them. We've been working with the smallest integer. So when we're having consecutive integers or consecutive even integers, I use my variable as the smallest one. So if I'm going to find the sum, okay, because here, step 2, what number goes with the variable? Well, there's nothing being multiplied by it because it says sum. So now I'm going to look at step 3. What other numbers are there? Is there any adding, subtracting, or totals? So I know here there's going to be adding, and I'm adding 4 consecutive integers. So I draw my lines to make sure I get all 4 of them. So 4 lines. 4 consecutive integers is negative 26. So I know that equals negative 26. Okay, so now, let me get that focused in a little bit. There we go. Now I have to say, remember, what is consecutive? Consecutive means in a row. So I just need to think of 4 numbers in a row. So I'm just going to pretend this is 1, 2, 3, and 4. Now I know 1 plus 2 plus 3 plus 4 does not equal negative 26. But these numbers are going to help me write my expression to solve for that. So if I say 1 is my smallest integer, then 1 has to equal x. If each of these terms have to include an x, because I can't get to 2 without starting with 1, then I say to get from 1 to 2, I have to add 1 more to that. And again, to get 3, I have to start with 1, and to get from 1 to 3, I have to add 2. And the same thing for 4, but this time I have to add 3. So now I have my expression. I know in order to find these 4 consecutive integers, I need to combine x plus 1 plus x plus 2 plus x plus 3, and that's going to equal negative 26 once I solve. So I've wrote my equation. Now I'm going to solve. So we did this in lesson 4. We had to combine our like terms. So we're going to look at all of our x's. Each of these is the same as 1x. So total I'm going to have 1, 2, 3, 4 x's. So I have 4x. And then I'm going to combine my constants, which means they do not have a variable attached. They all are additions, so I'm going to do 1 plus 2 plus 3. And I know that equals a positive 6. And I keep that equal to negative 26. Now it's a regular two-step equation that you guys have been doing since 7th grade. You guys have mastered it. If I want to get this 4x by itself, I need to get rid of this plus 6. So I know I'm going to subtract 6 from both sides, 6 minus 6 is 0. I have 4x left on this side. Here you always need to be careful. When you type this into your calculator, you are going to type in negative 26 minus 6, exactly like it shows. And since I have a negative and I'm subtracting more from it, I need to get further into the negative. So I know my answer is going to stay negative. And if I add 26 and 6, I'm going to get negative 32. Not finished yet. I still need to isolate the x. This is 4 times x, so I need to divide both sides by 4. 4 divided by 4 is 1, or just x. Negative 32 divided by 4, just one negative means I have a negative still in my answer. So x equals negative 8. Now it tells me to check, but right now I have to plug negative 8 back in order to check into each of these terms separately. So I'm going to plug negative 8 in for this x. So I have negative 8 plus, I have another x, so now negative 8 plus 1. I have another x, so negative 8 plus 2. And I have a last x, so negative 8 plus 3. So now if I add all of these together, I have negative 8 plus negative 8 plus 1 plus negative 8 plus 2 plus negative 8 plus 3. I do get negative 26. But I didn't answer the question yet. So in this one, there's a specific question. We're actually trying to find what are all 4 integers. Right now, the only integer I know is x equals negative 8. So I'm going to look at each of these terms individually to find out what all 4 of those numbers are. So if this x is negative 8, that just equals negative 8. But this term is negative 8 plus 1. Now if I'm adding 1 to a negative, it gets closer to the 0 and I'm at negative 7. Negative 8 plus 2 is negative 6, and negative 8 plus 3 is negative 5. Then you can make sure that you have all of the integers. Zoom in a little bit again. They're all consecutive, 8, 7, 6, 5. Those are all in a row. And if you add all of them together, you do get negative 26. So we can double check and make sure our answer is correct. Okay, now what I would like for you to do is, using the notes that we've done and the 2 example problems that we have, I'd like for you to try numbers 5 and 7. This is from lesson 9 again. I want you to use the steps to help you solve problems number 5 and 7. Do when you get back. Thank you.